On this video, I'm going to talk about the second moment of area, or it can be called as the moment of inertia. So what is that? What is the second moment of area? So in my view, in my opinion, the second moment of area reflects the strength of the shape that the material can produce. For example, if you have the beam like this, right? If the beam is like this, if you have a point load in here, it will be very easy to bend this way, right? Sorry, it's very easy to bend this way. But if you flip it over just 90 degrees with the same area, the same amount of material, you're gonna have something like this, right? But now it's much stronger. It's the same point load. You can only bend it a little bit, just a little bit, because it's much stronger. Look, for example, with a ruler, it's very easy to be deflected, right? But if you flip this way, it's very hard to be bent, right? Okay, so if you look from here, you're gonna have something like this. Let's go with 5, go with 10. Same thing, if you look from here, you're gonna have something like this. Go with 10, go with 5. Alright. So what is the formula to calculate the second moment of area? So the second moment area about the x-axis can be determined as b multiplied by h cubic over 12 plus to the area of itself multiplied by the shift, which is a from itself neutral axis to the main neutral axis. I talk about this later. But because of the symmetric, so we don't need to worry about this one for now. Okay, so in this one, what will be the value? It will be 10 multiplied by 5 cubic over 12, right? So what will be the value? It will be something 104.2.16, yeah? This one would be 5 multiplied by 10 cubic over 12, and it will end up with, look how strong it is. See how many times it's stronger if we just flip the beam over 4 times. If you just flip it over, it's stronger 4 times. Same material, same area. Got 5 multiplied by 10 and 5 multiplied by 10. This same area, but it's much stronger, right? That's why engineer is so important. They save money while the structure is still strong. But is it the best shape? Do you think it's the best shape? No. I will prove it later. I'll prove it now actually. Okay, so let's say if you have that's amount of, let's say 50 mil and 126 mil. Alright, so the area will be just keep it in mind, okay? And the second moment of area will be 126 cubic over 12. It's gonna be 8.3349 to times 10 to the power of 6 millimeter to the power of 4, right? Just keep it in mind, this one, this number. Now, with the same amount of material, I'm going to create a much stronger shape for it. Look. This one is 15. 15. This is 100. This is 20. Okay, is that the same thing? Let me check. This one is 150. Okay, now I'm gonna call the shape, this one. We're gonna separate the shape. Okay, I call this one 1. This one is number 2 and this one is number 3, right? So 1, 2 and 3. So what is the area of the number 1? It's gonna be the 1500, is it? Right? What is the number 2? Number 2 will be 3000. And what is the number 3? Number 3 will be 1800, right? The total will be 6300 millimeter square meter. Same thing here, right? Same thing here. So as you know, the formula of the second moment of area about the x-axis will be x by itself plus 2a multiplied by dy over 2, or it can be right like this. It's much easier to understand. A and then d square. So the d in here is the distance from the neutral axis to the neutral axis itself. For example, the neutral axis is around here and the neutral axis of the shape 1 is here, so the d will be here. The d will be distance of this one. Okay, we calculate it now. So the y prime is the distance from the neutral axis of the shape 1 to the bottom, which means here. The shape 2 is this one, and the shape 3 is this one. Of the shape 1, it will be 7.5 because 15 divided by 2, right? Okay, what is the shape 2? Shape 2 will be 150 divided by 2 plus with 15, right? So it's gonna be 90, right? What is the shape 3? Shape 3 is going to be 15 plus 150 plus 7.5, right? Distance from here. So what is gonna be? So 172.5. Okay, so now we are going to calculate the y bar, which is the distance from the neutral axis to the bottom or to the top, but in this case I use the bottom one is the datum. So what is the formula? The formula to calculate the y bar will be the sigma of the y prime over the sigma of area. So it's very simple. It's not complex as it sounds. So in here we have 7.5 multiplied by 1500 and plus 90, 3000 plus this one multiplied by this one and then divided by this one, and this one, which is 1,500, 3,000, and then 1,800. That's it. That's the Y bar. You can create the Excel for it. I'll show you later. So it's gonna be what was that? 93. 93 by mu. So with the Y bar, that's a Y bar. Y bar will be 3.982. 928, sorry about that. Now we're gonna calculate the second moment of area of each shape. So let's call the number 1 first. What is the formula before? The formula of the second moment of area. I didn't write it here. Okay, that's okay. So the second moment of area about the x-axis will be the BH cubic over 12 plus to the A D. So the BH is 100. H is 15 divided by 12 plus to the area here and multiply by the shift. The shift is the distance from here to the neutral axis, right? Of the shape one, this one. I show you the trick, okay? Just use this one, which is 7.5, and then you minus to the Y bar, which is 93.928, and it will be your answer. True. Okay, so it's going to be 11.233 multiplied by 10 to the power of 6 millimeter to the power of 4. Same thing. You do the same thing with the shape 2, which means 20, and you have this one over 12 plus to the area that we calculated here is 3,000, and then the shape, which means the 90, and then minus to the Y bar to power up 2. Yeah, so I calculated here. I have the value of 5.671. Same thing with the number 3. I have the I3 equal to this one to the power of 6 millimeter to the power of 6. Right? I1 plus the I2 plus I3, and so the total of them will be 28.05 to the power of 6 millimeter to the power of 4. Alright, so this one, if you compare, the same, it's same material, but look, this one, it's only 8.3 compared to this one. Yeah, it's 3.4 times stronger than the rectangle one. Rectangle one not good. This one is good. This one is good. But is it the best? Is it the best? No, not yet. Depends on the case. Alright. So this is second moment of area. Okay. On the next one, I'm going to talk about the shear flow and the first moment of area. Alright.